So this is the first question here, right? Feel free to use any short. That quick question. Did we do this one last week? I just want to make sure. Remember, that square root is a problem, right? Meaning that you throw away the square root and replace it with the power of a half. That's the easiest way to go about the question. Now you notice you have two groups of x, right? One on top and one underneath. That's a clear case of using what? The quotient rule to do what? To differentiate, right? Great. Right, so that's the first thing. So let's use. So u is going to be equal to sine 3x, and v is equal to 4x plus 1 to the power a half. And of course, you need to differentiate each portion. For v, feel free to use the shortcut, because that's a hostage situation. And I showed you all how to differentiate a hostage situation. Right now, today, guys, I'm going to be moving a little bit faster with the simple differentiations like the hostage situation. I think I have to in order to make a proper dent in the syllabus. So my assumption is that you know, I remember last week I had a talk with you guys. Make sure and revise a little bit before you come to class so we don't move too slow in class. All right, so answers are coming up on this. Look at the differentiation. So the first one, if you differentiate u and x, well, by now we know we get du dx. So you're going to get 3 cosine 3x. How much people have that for the first differentiation, right? I gave you those rules 2 weeks ago. Remember, when you differentiate sine, you get positive cosine, and whoever is touching x, you just drop him in front. For the second differentiation, you can use the shortcut for the hostage rule. Differentiate v and x. You're going to get dv dx. Remember what you do? You throw the power in front. I'll simplify it just now. So you throw the power in front, that's the half. You write back the brackets exactly as it is, and you minus 1 from the power. A half minus 1 is minus a half. And then you differentiate the brackets in your head. When you differentiate 4x plus 1, you will get 4. When you differentiate it in your head, whatever you get, throw it on the outside as well. So we throw the 4 on the outside. Now we can obviously simplify that, right? 4 multiplied by a half is 2. So in a few seconds, I will change this to 2 because 4 multiplied by a half is 2. We good up to there, guys? Everyone have up to there? Right? And it's just to throw everything into the formula now, and that's pretty much it. It's not going to look too pretty, right? But you throw it into this formula. You have 5 things to substitute in. Just substitute it. If you could simplify, try a thing when it comes to simplifying it, right? All right. So as promised, I'm going to simplify 4 multiplied by a half, and you will get what? 2. All right. So it's just to put all 5 things together. We're going to take v d multiplied by du dx. It's just to follow the format of the formula, right? So dy dx, need all the space I can here, is v. Where's v? V is 4x plus 1 to the power a half multiply by what? Du dx. Where's du dx? That's 2, open brackets. No. Du dx is over here, sorry. Du dx is 3 cosine 3x. 3 cosine 3x. You must put a minus sign. That's this here. Where's u? U is sine 3x multiplied by dv dx, which is 2 4x plus 1 to the power minus a half. And of course, here, guess what? You put it over v squared. 4x plus 1 to the power a half. And what we have to do that? We have to do what? Square it. Now, I'll let you know something. Well, remember, when powers are separated by brackets, you multiply the powers. So if you take to the power a half and multiply by squared, a half multiplied by 2 is 1. So remember, anything to the power of 1 is itself. So you can simplify it there if you wish. No, not if you wish. You have to do that one for sure. Right, but here's what. I'm just going to leave the answer up to here because I know everybody's going to attempt to simplify it in different ways. But once you have up to here, I'm good to go. Right? That means you understand the concept as you understand the concept. Right, so a good few people reach here, and some people actually took the time to type out the answer. So thank you for that, right? So this here is a popular trick question. Let me explain why it is a trick question. Everyone agrees that if I have sine x, when I differentiate sine, don't I get cosine? I remember when I put dy dx here. I gave you that in your formula sheet, right? And when you differentiate cosine, you get minus sine x. We all know trigonometry has three things, right? Sine, cosine, and tan. How come I didn't tell you what we get when we differentiate tan? Doesn't that seem strange that I would give you a formula to differentiate sine? I would give you a formula to differentiate cosine. But when it comes to tan, so didn't give you anything. And there's a reason for it. Don't get me wrong. In Form 6, there is a formula. They will give you the formula when you differentiate tan to tell you what you will get. But in CXC Form 5, you have to work it out. You don't get to memorize it. So I'm going to show you how to differentiate tan x. But first of all, you have to remember trigonometry from last term. How much of you all could remember this formula? Tan x is the same thing as sine x divided by cosine x. Look back in your notes. I just don't want you to tell me yes, sir, right? I want you to go back into your notes and physically find where I gave you this formula when we were doing trigonometry last term. That tan x is the same exact thing as sine divided by cosine, right? Go and look for it. Go and look for it, right? There are advantages to actually looking for it in your books, right? Right? Well, right. Take a few seconds, look. All right. So that is a formula, right? So when in the exam, when they ask you to differentiate tan x, you are supposed to know in the exam that tan x is the same thing as sine divided by cosine. So which rule do we use when one group of x is being divided by another group of x? It's the quotient rule. So here's what. In the exam, you're going to have to show the whole procedure. You call the top U and the underneath V. And then you do the same thing that we just did just now. Okay? Right? Give it a shot, guys, and let's see what we get here. Think. Remember, in the quotient rule, because you divided one group of x by another group of x, we always call the top part U. U is sine x. And the underneath V is cosine x. When you differentiate U, right? When you differentiate U and X, well, we know we get du dx. When you differentiate sine, you get what? Cosine. And when you differentiate, just now, cosine, you get minus sine x. So how much people have up to there at least, right? I kind of gave away that even before you started the question when I was doing a little bit of revision. Great. Right? Zarian, we good there? Right? I think that's how you pronounce your name. I think, right? Right. So it's just to put everything together now, no? It's just to put all five things together. So I'll write my dy dx here. I need all the space. We have to take v. How much is v? V is cosine x multiplied by du dx, which is another cosine x. I'm making sure. V du dx, right? Minus u. How much is u? U is sine x multiply dv dx is minus sine x. All divided by what? V squared. How much is v? Look, v here. Cosine x, and we do what with it? Square it, right? Now, and cos x squared is the same thing. They don't write it like that now. They just say cos squared x. They just put the squared over the s now. And any textbook would write it like that. Now we're almost finished, right? So cosine multiplied by cosine is cosine squared x. Sine x by sine x is sine squared x. But a minus and a minus. Look at it. If a minus and a minus here, you'll get what? A positive. Tell me something. In maths, I gave you a formula. Cos squared x plus sine squared x. What can you replace that with? What can you replace that with when we were doing trigonometry? Anytime you see a cosine squared plus, not minus, plus a sine squared, great. You just get what? A 1. And that's the answer. So when you differentiate tan, you just get 1 divided by cos squared x. But in the exam, you're not allowed to memorize that. You just have to do all the working for the examiner to arrive at 1 divided by cos squared x. Right? And the examiner will be very clear. He won't ask you, what is the differential of tan x? He will say, show or calculate the differential of tan x, which means you have to show all the working. If you just put the answer, you get 0 marks. Easy, right? And it's so popular. If you go back to your past papers, for those who started past papers, you will see this question quite a few times. So I hope you all remember this one for the exam. Right. So what am I going to do next? I'm going to show you what you could use differentiation for eventually. Now, the main aim of differentiation is to find gradient. Remember, I explained to you all on a curve, the gradient changes. The gradient will be different at each point on a curve. So you just use differentiation to find the gradient at any point on a curve. So let's start off with a past paper style question, right? You have a graph, right? In school, sometimes they just ask you to draw a graph. Like, for example, in school, they say, the teacher will say, bring graph paper to school. And he will say, draw y is equal to 2x plus 1. Or he might say, he might give you a quadratic, 2x squared plus 4x minus 5. But if you give you something complex, like one day in maths class, they might give you square root of x over 5. I mean, these questions have come very rare in the exam. The point is, sorry, not almost, every equation, you could draw it on graph paper. Some graphs are easy to draw, and some graphs are what? Hard to draw. Quick question. Do you think you know how this graph would look? Even instinctively, right? Do you know how this graph would look if you were to see it on if you had to draw that on graph paper? Look at that crazy equation. 2x to the power minus 1 minus 4 square root of x. You're not gonna, I mean, it's gonna definitely be a curve, but you don't know how that's gonna look. When you draw that on graph paper, let me say this is your graph paper with your x and your y axis. By the time you spend half an hour drawing that graph, it might look something like this. Or it might look something like this. Or, for all you know, it's going to look something like this. Up, down. You don't know. No, you don't need graph paper, guys. I just saying now, right? Is that when you draw that graph, you have no idea how that graph is going to look until you draw it. But tell me something. Let me say we get a real crazy graph, like the green graph there, right? Let me say when you draw this on graph paper, it looks something like this, real crazy. I'm going to put some points here, A, B, C, D, and E. If we were to measure the gradient at A, B, and C, we are going to get different values for the gradient, right? The gradient at A is going to be different to the gradient at C. And the same thing goes for B and E. So, long time before differentiation was invented, giving you a little story here, let's remember the only thing you know how to find the gradient of is a straight line, right? So remember how you find the gradient of a straight line. M is gradient, sorry. Well, gradient and dy dx is the same exact thing. How would you find the gradient of a straight line? Y2 minus y1 divided by x2 minus x1. That's from regular boring maths, right? So long time, if you had a complex curve or any curve, if you wanted to find the gradient at point A, you would have to take a ruler and draw a tangent at point A, a line that just skimming point A. And then you take 2 points on that line and use this formula, because this formula only works for what? A straight line. And if you wanted to find the gradient at point B, you would have to draw a tangent at point B and take 2 points on the tangent and use that formula. That used to be headache, right? Because when you draw in a tangent, it takes a lot of skill to draw a tangent. But luckily for you, if you want to find the gradient at any point on a curve, we now have something called differentiation. So here's the question. We want to find the gradient at this point on the curve, minus 2, 5. Here's the nice thing. We don't even have to care how that graph looks. We could find the gradient at that point without knowing how the graph looks and without even trying to draw the graph. Remember, all points have an x coordinate. The first one is always x, and the second one is always y. So the first step in doing this question is to differentiate this. Everyone differentiate that, and if you could, send the answer on the chat. Differentiate this expression for me. You all got here? Well, like I said, right, I had to move a little bit fast in class, right? And, well, this square root here, I'm going to replace that with the power a half one time, right? I'm going to replace that with the power a half. So we have two x's here. I'm just going to differentiate him separately and him separately, right? Throw the power. If for both of them, you just throw in the power in front and minus in one from the power, right? So throw the minus one in front. You have a 2 weight in there, and you minus one from the power. Minus 1 is minus 2. This one, you throw the half in front. It have a 4 weight in there, and then you minus 1 from the power. Simplify. Let me just simplify it here. Minus 1 by 2 is minus 2. And then we have x to the power minus 2 here. A half multiplied by 4. Well, we know a half of 4 is 2. And then we have x to the power minus a half. That's it. We have just differentiated it. Look for your mistakes. Some people have the mistakes based on the answers they sent. But most people had it correct. Look for your mistakes. Now, here's the thing. I know some of you all don't like those negative powers. I know you're probably just rolling your eyes. On your calculator, when you're typing in a power, you can type in a negative power or a positive power. Some people know how to use the calculators properly. Some people have a little problem with it. So I'm just saying, if you don't like this, I'm gonna circle it. You don't like this negative 2 power and this minus a half power, and we could just throw it underneath and the powers will become what? Positive. So you can write it like this if you want. You throw the x to the power minus 2 and you get x positive squared. Minus 2, throw the x underneath, you get positive a half. But remember, a positive half is the same thing as what? Square root. So if you want to replace it with square root, you can. Right? So this, you don't have to. I know some people are going to ask me if you have to. Obviously not. That is optional. So, but tell you what, just for today, or you take down my answer. So when I'm doing the work, it will be easier for you, right? Let's pretend you all have my brain and you decide to do that thing in blue there. We are not finished. The examiner has asked us to find the gradient when x is how much? At the point minus 2, 5. So to find the gradient at this point, remember, dy dx is the same exact thing as gradient. So if we want to find the gradient at this point, we just have to pretend x is how much? Minus 2. Now, there's a small mistake in the question. I just adjusted the question, right? I made a small mistake. This is supposed to be the point. I made a mistake. Oops. It's not supposed to be minus 2, so everyone just erase it there. It's supposed to be 4. My mistake, not minus 2. 4. So if we want to find a gradient at this point, all we have to do is go to the blue expression and replace x with what? 4. And that is it. Now, some people are going to ask me, what to do with the 5? Well, why the examiner give us the 5? It seems like we're not using the 5 in the question. That 5 is just there to distract you. That 5 has nothing to do with the question. To find the gradient, we need the x value. And the x value they gave us was 4. All right? Send your final answer for the gradient. Replace all the x's with 4. If you get a decimal, round it off to 2 decimal. Okay? And that's the end of the question. So we're going to replace all the x's with what? So I can erase my x here. Erase that x and erase this x and replace it with what? 4. Right? So I have minus 2. 4 squared is 16 minus, well, remember the square root of 4 is 2, right? 2 divided by 2 is what? 1, right? So 2 divided by 16 is 8. So you have minus 1, 8, minus 1. So I see what you all did. Minus 1, 8, minus 1 is minus 1 and 1, 8, or minus 1.25. Right? The working is there. It's simple. Just if you made a mistake with the signs, you can easily correct it. And that's the end of the question. The gradient at that point is minus 1 and 1, 8. A lot of people thought B was the answer. You see, I asked people which one had the greatest gradient, which part is the steepest. Now, a lot of people just assume because B was the highest point, that means B was the steepest. Highest and steepest is not the same thing, right? They're not really related at all. Remember, the steepest point is actually point A. That would be the hardest point to climb. Like if I drop you with a helicopter at this point, for you to move from that point would be very, very hard. But if I drop you at point B or at point C, look at it. If I draw a tangent at point B or a tangent at point A, you notice the line is flat. But if I draw a tangent at point A, it's very, very steep. You see, at point B and C, those are the places where the gradient is actually the least. This is where the graph is turning. Now, let me explain what I mean by that. You all notice that before B, the graph is going up, and after B, the graph is going down. Isn't it turning? Isn't it going from up to down about point B? What about point C? Before point C, the graph is going down, and right after part C, point C, point C, the graph is going up. It's turning, your direction is turning. So you know what you call these points? Take a guess. Turning points. So B and C are what we call turning points. And another word for turning points is stationary points. Okay? I think I have the note on the next page. But the point is, at turning points, the gradient is the least. And guess what the value of the gradient is? Remember, dy dx is gradient. At turning points, the gradient is always what? 0. How much of you all remember hearing that in school? That the turning points, at the turning points in a graph, dy dx is 0. In other words, your gradient is 0. Okay? So I think I have a note on the next page here, right? So let's go, right? Let's keep that in the back of your head. But what I'm going to get at is this. Because we know that the gradient at a turning point is always 0, that could help us find the turning points. We could figure out where the graph will be turning, like going from up to down or down to up, without even drawing the graph, which is amazing. Now, one thing you have to know, there are 2 types of points. The one that's shaped like a mountain, it going up and then down, it's called a maximum point. I'll just put MAX. C, you notice it going down and then up. It looks like a valley rather than a mountain. Guess what you call that type of turning point? A minimum. The name makes sense, right? The mountain is the maximum and the valley is the minimum. Okay? So let's just go to the next slide. I think I have everything else here summarized. Well, sorry, I don't already have it. But I'll put in the notes here. So here we have a graph, right? I'm going to call this point A, and I'm going to call this point B. A is what type of turning point? A maximum. And B is what type? A minimum. We know at any turning point, whether it's a maximum or a minimum, dy dx will always be what? 0. So the gradient at point A is 0, and the gradient at point B is also 0. We have a little problem here. Let me explain what that problem is. If I told you, and this is all I tell you, right? If I told you we have a point and the gradient is 0, dy dx is 0. That is all I tell you. What kind of point am I talking about? Am I talking about a maximum or am I talking about a minimum? Well, you don't, the correct answer to this is you don't know. You don't know whether I'm talking about a maximum or a minimum point, right? Because a maximum or minimum point is what? Has a gradient of 0. So how do you figure out now which one am I talking about? There must be a certain way to figure out whether I'm talking about a maximum or a minimum. And differentiation has a method. So there's a retract. At a maximum or minimum, dy dx will be equal to 0. What you need to do is this now. You need to differentiate one more time. Yes, you heard me. When you differentiate y, and you just get dy dx. But guess what? If you take dy dx and differentiate it again, you get something called d squared y dx squared. Sounds crazy, right? So you could actually differentiate dy dx. And if you work out d squared y dx squared, if you work it out and you get a positive value, the point is a minimum point. If we do calculations for d squared dx squared and we get a negative value, you get a maximum point. It means I'm talking about a maximum point. A maximum looks like this and a minimum looks like a value. Now, I know it's the opposite. Most people associate positive with maximum and negative with minimum, but it's actually the opposite. That used to catch me in school. A positive value for d squared y dx squared is actually a minimum point, and a negative value is talking about a maximum point. Okay? Take down everything on the screen. Let me know when you're finished. And the only way this is going to stick in your head is if I do practice questions. All right. For the curve, find the stationary points. Now, anybody can know, anybody recognize that equation? Isn't that a quadratic equation, right? Now, a quadratic could either be shaped like this from maths class, or it could be shaped like this, right? If it's shaped like this, then it's a minimum. And if it's shaped like this, it's what? A maximum. We have to do what? For this curve, we have to figure out whether it's a maximum or a minimum, and also the coordinates of the maximum or minimum point. Do me a favor, just take down the question. This is the question, and we will work it out together as a team, okay? Right. So when we differentiate the 7, we're going to get 0. When we differentiate minus 2x, we're going to get minus 2. And when you differentiate this, you throw the power in front and minus 1 from the power. That is what you get when you differentiate that expression. Basic differentiation from the first day. Now, what do we know about stationary points? At stationary points, the gradient is what? 0. You get a flat line. Remember, I showed you all that. So, isn't the expression for dy dx isn't that equal to minus 2x? So at a stationary point, if we're looking for a stationary point, whatever expression we get for dy dx, you always put it equal to what? 0. And then you solve for x. You think you all could do that for me? Solve for x. Get x on one side, everyone else on the other side. Please pay attention to your signs, right? Don't worry, I will repeat it again just now so you don't get confused quickly. So you want to solve for x, right? So I'll just put it here. Minus 2x is equal to 0. We want to solve for x. Draw across minus 2. You're going to get positive 2, right? Minus 2x is equal to 2. The minus 2 is a multiply. Throw across the multiply. So x is equal to minus 1. Look for your mistakes. Just look for your mistakes. X is what? Minus 1. So here's the thing. Let me tell you how much of the mystery we have solved already. It seems that on the graph, when x is minus 1, there is a stationary point. So it's like a mystery you're trying to solve, right? So when x is minus 1, there is a stationary point. And there are 2 types of stationary points. Isn't it a maximum, or it could be a minimum? How do we know which one it is, right? To know which one it is, we have to differentiate one more time. So everyone, you see this expression here, dy dx. I'll write it in back here, which was minus 2x. Differentiate that one more time and tell me what you get. Differentiate this expression and tell me what you get. You should be able to do that one in your head. Differentiate that. Let me know what you get. John, correct. Tani, correct. Vishala, Mackenzie, correct. Right. -2. You see this guy here? The d squared y dx squared, he is the decider. He is the one that says, hey, you see the point? You see this point here? I will tell you whether he is the maximum or a minimum. So you notice when we differentiated it, we got -2. Isn't this a negative value? When it's a negative value, what kind of point would it be? A maximum, because d squared y dx squared turned out to be negative. So he's the one that walks up to the point x -1 and says, hey, you will be a maximum point. So when x is -1, we have a turning point, and it's also going to be a maximum. But didn't the examiner ask us for the point? Doesn't a point have an x coordinate and a y coordinate? Isn't the x coordinate -1? What's the y? What's the corresponding y coordinate? And we have to go to this equation here now and replace all the x's with how much? -1. So go to the first equation now and replace all the x's with what? -1. And tell me what the corresponding y coordinate is. And then you finish the question, because I ask you for the stationary point. It must have an x and a y. And of course, it's important to know whether it's a maximum or a minimum. We'll do another example just now, don't worry. Right? But let's finish off that little part there. Remember, we're replacing all the x's with what? -1. I'll put it in brackets, right? I think I did a good job there, right? So 7 -2 by -1 is +2. Minus, oh, by the way, this -1 in brackets, -1 squared is +1. But who's waiting on the outside? Minus. Okay? -1 squared is +1. +1 by a minus is a minus. 7 plus 2 is 9. -1 is 8. The answer is 8. So at the point -1, 8, we have what? A maximum point. Can we look for a mistake there? Look for a mistake. Changing up the question. Let me erase this here. That's all. Second, you can easily change this up. So let's say we have 5x squared minus x minus 8. Find the station, not just the type of stationary point, but the coordinates of that stationary point. Good luck. Take 2 minutes. Shouldn't be too hard. We know we have to differentiate once at least, right? So when you differentiate once, you get dy dx, and you're going to get 10x minus 1, right? I think everyone could at least do up to that part, because remember, x is the same thing as 1x. There's just no examiner in the right mind going to put that 1 in for you. So the minute they start to talk about stationary points, you suppose once you get the expression for dy dx, you always put it equal to what? 0 always, or even think about it too much. You always put that, and you always do what? Solve for x. Right? You always solve for x here. Now, remember, when you're solving for x, right? Now, I think it's just these signs, guys. You're throwing across -1, but when you throw across -1, you just get what? +1. And when you throw across the 10, which is a multiply, you get a divide. So you're definitely going to get x is 1/10. Or, to me personally, I would prefer to put 0.1. That's such a nicer value, nicer on the eyes. Okay, great. Now here's the thing. When x is 0.1 or 1/10, we know we have a stationary point, right? It's just that we don't know. So let me put it here. We have a stationary point. We just don't know if it's a maximum or if it is what? A minimum. How do we figure that out? Well, we have to differentiate one more time. So when you differentiate one more time, look at this expression. When you differentiate 10x minus 1, and you're going to get 10, you can do that in your head, right? So when you differentiate that, we get 10. Ask yourself, is this a positive value or a negative value? Well, 10 is clearly positive 10, and a positive gives you what? A minimum. So we know the type of stationary point we're dealing with now is minimum. So to finish off the question, we have the x value. We know the x value is 0.1. We just need the y value. So we go back to the first equation and we replace all the x's with 0.1, because when x is 0.1 and we work this out, it will give us who? The y value that we are looking for. Right? So you just need to work out that, but I can't do that in my head, but let me see. 0.1 squared multiplied by 5 minus 1 multiplied by 0.1. Anybody getting this? Minus 8.05. This is also the same thing as minus 8 and 1/20th. But minus 8.05, right? And that's it. Well, this is an easy question. This is an easy question, right? The question can obviously get harder, right? But this could actually come in the exam. In case you're wondering, you might get a 3 marks for this. Not too much. Did the question change yet? No, I don't think it changed. Oh, look at here. All right. That's that one. All right. Now, the only assumption is right now, I can't do back this one in class, right? The only assumption that I'm going to go with here is that everyone could solve a quadratic, right? I could go with that as I have to, because we did that the whole of last term. We had enough time to perfect it. We had homework on it. So guys, that's the only part I'm going to skip, right? Because if you can't solve a quadratic by now, that means you haven't been doing my homework and revising, okay? So take down this question, and are we going to find the stationary points for this particular equation, right? All right. So when we differentiate this expression once, we're going to get dy dx. Anybody got 9x squared minus 6x minus 8? In other words, when you differentiate it, we got a quadratic. Look at it. 9x squared minus 6x minus 8, right? Obviously, when you differentiate 5, how 5 doesn't have an x, you're going to get what? Nothing. Great. Once we differentiate, I don't care if the equation looks complex. The rules are still the same. When you differentiate, to find the stationary points, we always put it equal to what? 0. And when we put it equal to 0, what we do? We solve for x. So always put the dy dx equal to 0 and solve for x. So here you have your quadratic. This is your A value, this is your B value, and this is your C value. Solve for X. But here's the thing. When you solve a quadratic, you get how much answers? 2 answers. So we're going to, in the other questions, when we solve for X, we only got 1 answer. This time we're getting 2 answers. So what are we going to do, right? Take a 2 minutes and solve the quadratic. Now, if you can't solve a quadratic, I will obviously put down my answers, the final answers for the quadratic, right? And of course, when you get some time, you could probably go but revise your work on how to solve the quadratic and see how I arrived at those answers. But solve the quadratic and send the answers on the chat. Feel free to round it off to 2 decimal places, right? Now, just take my word on this, right? I'm real sure about my answers, right? When you solve the quadratic, you're going to get 2 answers. The first answer is going to be 1.33 or 1 1/3. And the second value, right? I'll call it x1 and I'll call it x2. Is supposed to be minus 0.67 or minus 2/3, right? Take my word. I'm real sure it's those 2 answers, right? So I know some of y'all will put the fractions. You'll put 1 1/3 or 4/3, and some of y'all might put what? Minus 2/3. I go into 2 decimal places. Now, we have 2 values for x. So here's the thing. When you have 2x, both of them cannot be a maximum and both of them cannot be a minimum. One has to be the maximum and one has to be what? The minimum. So to figure out who is the maximum or the minimum, right? We need to differentiate one more time. So could you all differentiate this expression one more time? The one with the 9 in it? Differentiate it one more time. But you won't get a flush answer. You will get an expression. That should be easy. You can do that one in your head. Anybody getting this? 18x minus 6. How that looking? 18x minus 6. You throw the 2 in front, right? Great. So this expression is the one who tells you if x1 and x2 is a maximum or minimum point. But here's the thing. We won't know whether it's positive or negative until we insert the value of x. The last questions, it didn't have an x here. You got a flush value like minus or positive. This one, the outcome is uncertain unless we insert what? The x value. So do me a favor. Insert x1 into the tester, into the tester equation. Replace the x with what? 1.33, and then replace the x with minus 0.67. So that's how replace x1 equals to 1.33, and then after, in the same equation, replace it with what? Minus 0.67. And tell me if you get a positive value or a negative value. And that will tell you whether it's a maximum or minimum. 18, replace it with 1.33 minus 6, and do the same thing over here. Replace it with 0.67. But this one, I'm getting, let me see, 17.94. And for the next one, I'll put the answer underneath here. I get in minus 18.06. Looking correct? Easy stuff, right? So that means for the when x, look at the value we get. isn't 17.94 a positive value? Isn't the one underneath, the 18.06, isn't that a negative value? So when x is 1.33, what kind of stationary point is that? A maximum or minimum? When x is 1.33, when we put x 1.33 into the tester equation, he gave us a positive value. So what kind of point is this one? A minimum, correct. And I mean, you can't just make the assumption if this one is the minimum, then the other one is automatically a maximum. But make sure and do the working for it. So this one here is what? Since we get a minus value, it's a maximum. Now, I'm not going to make you do this, right? Because this question is a little bit crazy, right? But if we wanted to find the corresponding y coordinates, right? You see, for the first point, x is 1.33. That means we have to go to the first equation and replace all the x's with how much? 1.33. And that will give us the corresponding y value. And then for the next point, we have to go and replace all the x's, but this time with minus 0.67 to get the corresponding y coordinate. Right? I'm going to trust that you all could do that, right? It would just, I know you all are tired and it might be a little too much for tonight. But you all understand the concept? This one, when you differentiated a second time, it wasn't clear if it was positive or negative. You had to insert the x value in to determine whether it was positive or negative. I know you all need more practice on this, right? This takes a lot of practice, right? So we have 2 more weeks with differentiation. After that, we're going to move on to integration, right? I just want to be clear. How much of you all finished with the homework, the AP, the arithmetic progression? I've been asking about 4 weeks now, right? So guys, I don't think we have an excuse. The reason I'm asking is because next week I want to assign some new homework, right? Right? Great. So I want to make sure you have that cleared up so the other homework doesn't pile up on top of you. Okay? So, right, and Javi or Javi, when you come to class, you have to use your full name. I need a first name and a last name because I can't take a role. So send me a last name, please. It have more than one Javis in the school, or people start with J and whatnot. So I need to make sure. Right. So with that in mind, right,